So what we have here is a log equation, and if you notice, the subscript x is the base. So what we're going to do is we're going to follow this little rule that works pretty well for us, and we call this circle the base, run the race. So let's look at this. So we circle the base and run the race. Now, my suggestion to you is you have your notes. You should be open to this page with question number 1 there, and I would definitely put this at the top of the page, circle the base and run the race. Okay, so in this case, your base is that subscript x. Now, when we run a race, we have to cross the finish line, right? So we kind of, what we do is we look at the equal sign right here as our finish line here. So we have to cross over that. So when we say circle the base, run the race, we circle this tiny little subscript right there, okay? And when we run the race, we cross the finish line. We're crossing the equal sign. And so we draw like a little arrow to what's on the other side of the equal sign. All right, so what that does is that helps us form a new equation, and we're taking it out of log form. So that base x becomes the base. And when we run the race, when we cross the finish line, what we're drawing the arrow to, in this case the 1/4, will become our exponent. So we're going to have x to the 1/4 equals, and then the term that's left over, in this case that's the radical 5. So what we've done is we've taken a log equation and we've taken it out of log form by doing circle the base, run the race. Okay, the more we do this, the easier I think you're going to find it. All right, so now if we look at this, we have an exponential equation and we have an exponent that we need to get rid of because what we're trying to do is solve for x. So what we can do is we can take that power of 1/4, and really what we want to do is we want to just make that x equals. So if we multiply the exponent by its reciprocal, what I'm doing then, if you notice, 1/4 times 4 will just give me x to the first, which is what I want because I'm trying to determine what x is equal to. Okay? Now, obviously, what I do on one side of an equal sign, I need to do on the other side. So this is also going to be raised to the 4/1 power, which is really just to the 4th power. So I'm going to leave it like that if that works for you. All right, so now if we look at that, that's really radical 5 to the 4th power, which is radical 5 times radical 5 times radical 5 times radical 5. This is just one way of looking at it. Okay, there are others. So, well, we know that radical 5 times radical 5 is just 5 times, then another radical 5 times another radical 5 is 5. So then our answer would be x equals 25. And there we go. And that would be our final answer. Now, again, please make sure that you're writing these answers and all the work that leads up to it in your notes, and make sure at the top of the page you have circle the base, run the race. Alrighty, so let's look at the second one, which is actually number 3. We're going to do the same thing that we just did on the last one. So we're going to circle the base, which is that subscript, circle the base, and we're going to run the race. Remember, we cross the equal sign, and we draw an arrow to the number that's on the other side of the equal sign. So that subscript that we just circled will become our base, and what we drew the arrow to will become our exponent. So that's 3 to the -2 equals, and then whatever's left over, in this case it's the x, goes over here. Okay, so now at this point all we have to do is solve. X is already by itself, so we just have to figure out what 3 to the -2 is. Well, we could cheat and we could put it in our calculator and then hit math fraction. Or if you recall, I'm going to be a little more mathematical here, 3 to the -2, remember when we have a negative exponent, we can make it positive by bringing it down, in this case, to the denominator, because right now, as it stands, if we look at it right here, we can see that this is not a fraction, so we made it a fraction and flipped it down to the bottom, which then would give us a positive exponent. Okay, And then we know 3 to the second is 9. And so our answer is x equals, well, that should be an equal sign, sorry guys, 1/9. Again, please make sure that you're putting these notes in your packet. All right, let's look at number 5. So the same thing again. We're going to circle the base, we're going to run the race, and we're going to take this log equation and we're going to take it out of log form. So our base is going to be z, our exponent is going to be to the -3/2 power, and then we're going to set it equal to 125. All right, so this is similar to number 1. So if you go back and you look at number 1, you can see what we did was we took the 1/4 power, and the way we got rid of that was by multiplying by its reciprocal. So we're going to do the same thing here. I want to get the z by itself, so I'm going to get rid of that -3/2 by multiplying by -2/3 a power. And I'll do the same thing over on the right-hand side, because what you do on one side of an equation, you need to do on the other. Now remember, what we're doing by doing that is that's going to cross out these exponents right here, and that will just get the z by itself, which is what we're trying to do. Okay, so I'm going to do 125 to the -2/3 power. Now remember, when you have a negative exponent, to make it positive, we're going to, in this case, we're going to make that 125 come down to the denominator, and now what that does is it makes that exponent a positive. Okay? All right, we're going to keep going here. So now I'm going to do power over root. So in this case, my root is 3, and my power is 2. Okay? Because again, remember, power over root. Power over root. So my power is 2, my root right there is 3. Okay, so then I'm going to ask myself, let me just move over in this direction here. So I think the easiest thing to do first is to take the cube root of 125, and we can do that in our calculator, or we can do that in our brain, and that would be 5, and then we just need to then do the power, which is to square that, which would be 1/25. And there's your answer. Again, don't forget, you should be putting these in your notes. Okay, so number 7, this one looks like lots of fun, right? So we're going to start it off the same way. Got a few more x's in here, so that's going to make this interesting, but don't you worry. You have the power. So we're going to take that x plus 4, we're going to raise it to the second power, because we're circling the base and we're running the race. So I'm going to do x plus 4. Let's raise that to the second power. And remember, we set it equal to what's left over. Well, in this case, that's the binomial 17x minus 4. All right, now, remember when we have a quantity and it's squared, that's the same thing as writing that quantity 2 times. So in this case, we're going to have to double distribute. So much fun. Okay, so I'm going to get x squared plus 4x plus 4x plus 16 equals 17x minus 4. Remember, you should be writing this down in your notes. All right, so if I simplify the left side, I can add those 4 x's and get 8x plus 16 equals 17x minus 4. Now I'm going to move everything to one side because I see that I do have a quadratic here, and I see that because I have an x squared term. So I am going to subtract 17x from both sides. And because I'm lazy and I don't want to do this in a separate step, I'm going to add 4 at the same time as well. So what that will do is that will make that right side just be equal to 0. So I'm going to get x squared minus 9x plus 20, that look like a plus, equals 0. Okay, so now I'm going to do a little bit of AM action. So I want to figure out what adds to 9 and will multiply to 20. So that would give me 5 and 4. So x minus 5, x minus 4, and if you look at that, -5 and a -4 does add to -9, and -5 times -4 does multiply to a positive 20, so we're good there. Alrighty, let's t-chart this, and we get x equals 5, and we get x equals 4. Now, we need to just be a little bit careful here because we do need to check our answers when we have something like this, okay? Because what we need to do is we need to make sure that our answers that we got, our two answers, don't make this base be 0 or a negative number. So in other words, this base, when I plug in either one of my answers, has to be greater than 0 in order for this to work. So if I take this x equals 5 down here, and I plug it in right here, you see that I will get 9, and that's greater than 0, so we're fine. Let's go to the x equals 4. That's our other answer. We're going to check that by plugging that in here. And again, we want to get something greater than 0, which we will, so that's fine. Okay, so both those answers work so far. The other place that you really need to check it is over here in the 17x minus 4. So that also has to be greater than 0 in order for these answers down here to work. So I'm going to take this 5, and if I plug a 5 in here, I can do 17 minus 5. Okay, and when I subtract 4, that's definitely greater than 0, so we're fine. I'm going to do the same thing with x equals 4. Okay, so if I plug in 4 here, 17 times 4 is certainly large enough that when I subtract 4 from it, I'm going to get something greater than 0. Okay, so I'm going to say it again, and I know I'm kind of being annoying, but I don't really care. When you do this, you have to make sure that these two answers, that you check them in two spots, for that as well as this subscript. And neither of those two things, okay, when I plug my answers back in, neither of these two things right here can be 0 or less, okay? So these two things, when I plug in either one of my answers, have to be greater than 0, okay? And since they are, I've got two answers. All right, so I think you're on your way. Make sure, again, that everything is written down in your notes. Okie doke, bye.